Okay, today we're going to be talking about the sum and difference formulas. And essentially these formulas enable us to find the trig values for angles that are not on our unit circle. So let's say we wanted to find the cosine of 75, which we have here for letter A. 75 is not on our unit circle. However, we can think of two angles that are add up to 75 or subtract to 75 that are on our unit circle, and we know some things about those angles. And so basically, here are the formulas. You will be given those formulas on a quiz or test. You just have to know how to use them. You have cosine of A plus B, and pay attention here, is equal to the cosine of the first angle times the cosine of the second angle minus sine A sine B. And then, of course, you have cosine of A minus B, and that's going to have the plus here. So you have to remember that the sum formula for cosine, the signs are reversed. If you're adding the two angles, then there'll be a minus here. If you're subtracting the two angles, then there's going to be a plus here. Sine of A plus B is indeed sine A cosine B plus cosine A sine B, and so on and so forth. So let's just jump in. We have cosine of 75. We can break that up into the cosine of 30 plus 45. And there's all sorts of other combinations that you could use here to get 75. It really doesn't matter. I'm just going to pick the most basic two angles that I can think of that add up to 75. And so we'll just go ahead and make a little triangle here. And so for 30 degrees, we'll put 30 right there. Across from 30 is 1, across from 60 is root 3, across from 90 is 2. So let's write out our formula here. This is going to be cosine of 30, cosine of 45. And because there's a plus here, I need to put a minus there and make it sine of 30, sine of 45. And of course, all of these are in degrees. All right, cosine of 30 is going to be your adjacent over your hypotenuse. That's going to be root 3 over 2. Cosine of 45, well, that's just going to be root 2 over 2 whenever you work out the triangle. And then sine of 30 is going to be 1 over 2, opposite over hypotenuse. And then sine of 45 is the same as the cosine of 45, so root 2 over 2. So you're going to multiply these together. You're going to get root 6 over 4, so root 6 over 4 minus root 2 over 4. And because these are different radicals, you can't combine them, so your final answer would be root 6 minus root 2 over 4. And for this problem, that's essentially as far as you can go. All right, now let's try this next one, 7 pi over 12. Now the last thing you want to do here is you don't want to convert it into two angles in degrees or whatnot. Just want to break this up into 3 pi over 12 plus 4 pi over 12. And of course, we know these will both reduce. 3 over 12 reduces to pi over 4, and 4 pi over 12 reduces to pi over 3. All right, so then now we can see that this is just going to be 45 plus 60. So essentially, we're going to be finding the sine of 105. I guess it's not a bad idea if you want to convert this into degrees at first, but you don't really have to. All right, so I'm going to run through this pretty quickly because these formulas are pretty self-explanatory. Sine of A, so sine of 45, cosine of 60, and because it's sine and it's a plus, then you're going to just use a plus right there. And then you'll put cosine of 45 and then sine of 60. All right, so then now we're just going to put root 2 over 2 here. We go back to this triangle, cosine of 60. If 60 is up here, the cosine would be adjacent over hypotenuse, so that's going to be 1 over 2. And what you'll notice is a lot of your answers are going to start looking very similar. And then you have cosine of 45, well, that's root 2 over 2. And then the sine of 60 is going to be root 3 over 2. So this is going to be root 2 over 4 plus root 6 over 4. So root 2 plus root 6 over 4. And like I said, a lot of your answers are indeed going to start looking very, very similar here. All right, so let's go ahead and see if we can find the answer for tangent. Run out of space here. Tangent of 75. Once again, we can break that up into the tangent of 30 plus 45. All right, so now we go to our little formula here, and we'll say tangent, I have to write pretty small here, of 30. And because there's a plus here, I need to use the top sign, so plus tangent of 45 over 1. Now using the top sign, so that's a minus. Once again, make sure everybody understands it. We're using plus, that's the top sign. So you need to use a plus here, that's the top sign, and a negative there. So minus tangent of 30 and then tangent of 45. All right, let's go back to 30 degrees. The tangent of that would be opposite over adjacent, 1 over root 3. So this is going to be 1 over root 3 plus tangent of 45 is 1 over 1. And then over on the bottom you have 1 minus the tangent of 30, which is 1 over root 3 times tangent of 45, which is just 1 over 1. Okay, so if we get a common denominator here, do that in orange, it's going to be root 3 and root 3. So our, and actually if we get a common denominator on the bottom, that's going to be root 3 and root 3. Running out of space, I apologize. So then let's finish this up here. This is going to be 1 plus root 3 over the common denominator of root 3. And then on the bottom we have root 3 minus 1 over the common denominator of root 3. So when I flip and multiply, these two are going to cancel out, leaving me with a final answer of 1 plus root 3 over root 3 minus 1. So basically these formulas are very easy, you just have to know how to use them. All right, now we want to go backwards. And so the idea here is that they're given sine A cosine B minus cosine A sine B. And basically we need to figure out two things. What formula this is. Is it the sine formula or the cosine formula? And then is it the sum or the difference formula? And then what is my A and what is my B? And figure out whether we're adding or subtracting. These are very simple problems. So this would be the the difference formula for sine. So I'll write this up here. This will be the sine difference formula. So essentially this is my A, this is my B, and this is my A, and this is my B. So essentially this is going to be sine of 42 minus 17. And so that is going to be sine of 25 degrees. All right, so that's pretty self-explanatory here. All right, so the next problem is going to be cosine of A cosine B plus sine A and cosine of, actually that should be sine right there. Every year I forget to change that. So cosine A cosine B plus sine A sine of B. So this is our cosine. Now you got to be careful, there's a plus here, and for cosine, when there's a plus in this formula over here, that equates to a minus in this formula there. So this is your cosine difference formula. So I will write cosine of 94 minus 18, and that's going to be 76. So this is the cosine of 76 degrees. Okay, in example 2, we want to prove the identity that the cosine of some angle shifted right 90 degrees is indeed actually the same as the sine of that angle. All right, so we notice that we have cosine of two angles that are being subtracted. So we can use the cosine difference formula, cosine A minus B. So that's going to be cosine of A, and then cosine of B, which is pi over 2. And if there's a minus here, we need to use a plus here because a minus here transfers into corresponds to a plus there. So plus sine of x, that's our A, and then sine of B, that's our pi over 2. Okay, this is 90. So the cosine of 90 is 0 because 90 is up here and the coordinates are 0, 1. That's your cosine and that is your sine. So 0. 0 times anything is 0 plus sine of x times this y coordinate of 1. So therefore, cosine of x minus pi over 2 equals sine of x. So the proofs in this section are very straightforward and pretty simple. Okay, we've studied the sum and difference formulas. Now we're going to talk about the double angle formulas. And so there's all sorts of formulas here. Essentially, each of these formulas is just derived by using the sum and difference formula. Let me give an example. You have the sine of 2x essentially is equal to 2 sine x cosine x. Well, if you just make the first angle x and also the second angle x, which is the sum of 2, which will give you 2x, then you can use the sum formula for sine, which is sine A cosine B plus sine B cosine A. Well, if A and B are the same, you just get sine x times cosine x plus sine x times cosine x, which is 2 sine x cosine x. So all of these are derived by using the sum and difference formulas. Now, we want to find all the solutions in the interval for cosine of 2x plus cosine x equals 0. So the idea here is essentially what you want to do is you would like to hopefully get you want to get the same trig function, if possible. It's not always possible. All the same trig function. And then you also definitely need to get the angles to be the same. So you want to get the angles to be the same. So in other words, you can't have 2x here and x there. All right, and that's where these double angle formulas come into play. So you have cosine of 2x. Notice sine of 2x only has one option. Cosine of 2x has 3 different options for different reasons. So you have to pick which one is appropriate. Now think about it. We want to get all the same trig function. We want to have only cosines. So then I wouldn't use this one because it has a sine squared. I wouldn't use this one. So I'm going to replace cosine of 2x with 2 cosine squared x minus 1. I'm going to put the minus 1 over here. And then I'm going to put the plus cosine of x there equals 0. Now we're going to treat this just like a quadratic equation. All right, we're going to factor this. Now, if you're having trouble factoring, you're going to need to practice that, okay? Because you're going to have to know how to factor. So this is going to be plus, and this is going to be minus. I know that because if you were to FOIL it, you would do 2 cosine x times 1. That's 2 cosine x minus 1 cosine x gives you the positive 1 cosine x, and you can go from there. So now these problems take a little bit of time actually. So you want to set them equal to 0. 2 cosine x minus 1 equals 0. So cosine of x equals 1/2. And then the other factor gives me a cosine of x equals -1. All right, so this one's pretty simple to get. The cosine of x equals -1. Well, that's just going to be over here on our unit circle. It's going to be pi, which has coordinates of -1 and 0. So one of our answers is pi. Let me put that down there. Here, cosine of x equals 1/2. Well, that's going to be where your adjacent is 1 and your hypotenuse is 2. There's going to be 2 angles on the unit circle because we've got to find all of them between 0 and 2 pi. So this is going to be root 3 over there. So 60 and -60. So essentially we have pi over 3 and 5 pi over 3, which is the same as 300 degrees, which is the same as -60. So essentially these are our 3 solutions to this problem. Okay, part B is a challenge problem. So you have sine of x plus sine of 3x equals 0. All right, so first thing we recognize here is that we have a sine of 3x. So we need to break that up into the sine of 2x plus x. And then, of course, sine of x from this part here. I'm going to leave the equal 0 off until the end. So now I have the sum of two angles. So I have the sine of A cosine of B plus sine of B cosine of A. And I still have this plus sine of x here. And this, of course, well, I just might as well write it each time. It's equal to 0. And so now we've got to do the double angle formula for sine. Now, there's only one choice for that formula, so that's just going to be 2 sine x times cosine x. But then that double angle formula is times this cosine x, so I'm just going to make this a cosine squared x. All right, so then plus sine of x. Now, here's where it gets a little tricky because we have three choices for the double angle formula for the cosine. So let's go through our choices. You could do cosine squared minus sine squared, but when I distribute this sine in there, I'm going to get sine cubed. Don't really want to deal with sine cubed. Or you could do 1 minus 2 sine squared. Once again, if I distribute this sine in there, I'm going to get a sine cubed. Don't really want to deal with that. So I'm going to pick 2 cosine squared of x minus 1. And don't forget the plus sign right there. All right, so now when I distribute, all right, I'm going to get, well, let's just get this one here, 2 sine of x cosine squared x plus 2 sine x cosine squared x. That's from this part, and then I distribute it here. It's going to be minus sine of x plus sine of x equals 0. All right, so what do we notice? We notice that this and this cancel out, and I'm left with 4 sine of x cosine squared x equals 0. Now I'm going to go ahead and replace cosine squared with 1 minus sine squared because that is our Pythagorean identity that we learned whenever we did all of our proofs. So now I'm going to set both of these equal to 0. So let's continue up here. 4 sine of x equals 0. Divide by 4, divide by 4. So I'm looking for the angles on the unit circle where the sine is 0 or the y value is 0. So that's going to be 0 and 180. So those two of our solutions right there. Now this one can be a little tricky. I'm going to set 1 minus sine squared of x equal to 0. I'm going to move the sine squared x to the other side and make that a 1. Actually, I made a mistake here. This should have been... Actually, no, I am doing it right. I was thinking of something else. So I'm going to take the square root of both sides. And whenever you take the square root, you must put plus or minus on your answer. So plus or minus 1. So I'm looking for the angles where the sine or the y value is 1. So that's going to be pi over 2. And that's going to be 3 pi over 2. So my answers are 0, pi over 2, pi, and 3 pi over 2. So this one has 4 solutions. Sometimes you have 5, sometimes you have 7, have lots of solutions. Okay, now we're going to talk about a third set of formulas called the power reducing formulas. These are probably the ones that we use the least, but we will talk about them. If you have something squared, sine squared, you can reduce that power from squared down to something that's not squared, raised to the first power. These are used a lot in calculus, but not so much in pre-cal. Cosine squared is the sum of them. Tangent squared has a different formula. So we want to prove this identity. So essentially we want to, okay, we'll just put here sine squared of x. And as we do with proofs, we're going to put a straight line, reminding ourselves that we're not allowed to work on this side. and we'll work exclusively on this side. So we have 1 minus, I'm going to replace cosine of 2x with 1 minus 2 sine squared x. That is your double angle formula for cosine. You say, well, how did you know to use that one out of the three? Well, think about what we're trying to prove. We're trying to prove something that only has a sine squared in it. So it would make sense to pick the double angle formula for cosine that only has the sine squared in it. All right, so now I have 1 minus 1, and then I have this minus and this minus are going to distribute and make a plus. So the 1 minus 1 is going to cancel, and then I'm left with 2 sine squared x divided by 2. And you can see where this is going. The 2's are going to cancel, leaving you with sine squared of x equals sine squared of x. Okay, the last set of formulas we're going to learn today is called the half angle formulas. And once again, all these formulas are pretty self-explanatory. You just have to know how to use them. Let's say I'm trying to find the sine of 15 degrees. That's not on my unit circle. And we want to make sure that we use the half angle formulas. Keep in mind that you could use the sum and difference formulas to get the same answer. It won't look the same because the formulas are different, but when you plug into the calculator, it will give you the same decimal. But we're going to use the half angle formula. So what you want to think about here is, how can I write 15 as some angle divided by 2? So 15 is half of 30. So that's why we call it half angle formula. Now, every year, students will get confused. They'll try to plug 15 into this formula. That doesn't make any sense because we don't know what the cosine of 15 degrees is. It's not on a unit circle, so why would you plug an angle in here that does not have values on the unit circle? The whole point is to be able to use angles you do know information of to find out information that you don't know. So you want to rewrite 15 as sine of 30 over 2. So 30, let me circle that in gold here. 30 is your u, and you're going to plug that into there. All right, so we're going to say sine of 30 over 2 is equal to, now you got to just talk about the plus or minus. You have to choose whether it's plus or minus. You don't put plus or minus on your answer. You have to go back and look. 15 degrees is in the first quadrant. It's over here somewhere. So you have to ask yourself, is the sine of 15 positive or is it negative? Well, sine is the y value going up. Everything's positive in the first quadrant, so you put a plus here or you just leave it off. Okay, so then you have 1 minus the cosine of 30 over 2. All right, so then the cosine of 30 is going to be root 3 over 2. So this is going to end up giving us 1 minus root 3 over 2 divided by 2. And make this a little bit longer there. All right, so if I multiply the top by 2 and the bottom by 2, I'm going to have to distribute this guy in. So my final answer is going to be 2 minus root 3 over 4. And that's going to be a positive value. All right, let's go ahead and do this one here. Pi over 8. All right, so pi is 180 over 8 is going to be 22.5. So we recognize that to be the same as 45 over 2. So we're looking for the cosine of 45 over 2. So 45 is the angle that I plug into the formula. All right, so we're going to go ahead and write cosine of 45 over 2 is equal to, once again, 22.5 is in the first quadrant. The cosine is positive in that quadrant. So you will say 1 plus cosine of 45, which I know is root 2 over 2 divided by 2. Same deal as last time. You're going to multiply the top by 2 and the bottom by 2. When you do that, the 2 is going to distribute in here. And so it's going to leave you with a big square root of 2 plus root 2 over 4. And really, essentially, that's all there is to these problems.